The next topic is packing fraction of BCC, that is body centered cubic structure. So this is the structure. This is similar to simple cubic. That means the 8 sides, the 8 atoms are common for all crystals, but this is one more atom is present at its center of mass of each unit cell. The first parameter I have to find is the coordination number. The coordination number means the number of nearest atoms present in the unit cell. That means we have to consider any one atom. So you consider this atom. You consider this atom. The nearest neighboring atoms are these 4 and these 4. That means the coordination number is 8. Next, I have to find out the nearest neighboring distance, that is 2r. I have to find. For that, I have to consider this diagram. In this diagram, this is the atom present at its diagonal, and this is the atom present in the center of mass, and this also diagonal. That means we have to consider a linear chain of atoms. That means we have to consider this atom, this mid atom, and this diagonal atom. Okay, or 1, 2, 3, or 1, 2, 3, any 3 linear chain of atoms. Here I consider this, and this, these 3 atoms. Okay, so according to the crystal edge, this is A, this is lattice constant, this is A, and this also A, lattice constant. Here the radius of atom is, this is 1/8 part, no, that's why this will be R. Here hemisphere, this is 2R having diameter, and the radius is R here. Now I have to find, this is A, B, C, this will be D. I have to find this resultant, that means AD we have to find. So we have to make a triangle. There is no triangle at all. I have to draw a line from A to C. Don't forget to draw this line. Then ABC is a triangle, and ACD also a triangle. So by using these triangles, I had to find out the resultant of this nearest neighboring atoms. That means the distance between 2 atoms I have to find. Here we are having 2 radius and 1 diameter also. Okay. For calculation, we have to know the Pythagoras theorem. So first of all, we have to consider the triangle ABC. Consider the triangle ABC. According to Pythagoras theorem, hypotenuse square is equal to side square plus side square. That means hypotenuse means AC square is equal to AB square plus BC square. Then AC square is equal to AB means small a, BC means again small a. That means A square plus A square. Then AC square is equal to 2A square. This is equation number 1. Now I have to find the value of AD, the linear chain of atoms, the distance between these 3 atoms. That means the 2 successive atoms, any 2 successive atoms. Again we have to apply Pythagoras theorem, that is AD square is equal to AD. That means consider the triangle ACD. Then AD square is equal to, the hypotenuse square is equal to AC square plus CD square. Now we don't know the AC square is, then AC square is plus CD square means A square. For safety I am putting brackets. We know from equation 1 AC square is equal to 2A square from equation 1. Okay, AD square. Then AD square is equal to 3A square. This is equation number 2. But this means A means with respect to the crystal edges. Now I have to find in terms of atoms, inside the atoms. But from the diagram, AD is equal to 4R, R plus 2R plus R. R plus 2R means 3R and R is 4R. That means 4R. Then AD square means, now put equation 3 in equation 2, means 4R square is equal to 3A square. Now I have to find from this 2R. That means 4R, apply root 3 into A. That means 2 into 2R is equal to root 3 into A. Then 2R is equal to root 3 by 2 into A. Then I have to put value here. The nearest neighboring distance, I have to calculate this much of equation. I have to solve. This is root 3 by 2 into A. This is called nearest neighboring distance. Next, third one is atomic radius. R is equal to root 3 into A by 4. That means if you multiply this 2 with this, and we will be getting R. Fourth one, the lattice constant. The lattice constant A is equal to, then A is equal to 2 into 2, 4R divided by this root 3. Then 4R by root 3. You have to remember these parameters, which is very important. 4R by root 3. A is equal to, for BCC. Next one is, the fifth point is the effective number of atoms. That means the number of atoms present in the unit cell. That is, here like simple cubic, 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. 8 atoms are there. 8 means 1 by 8th parts. These are only 1 by 8th parts. All the atoms are having. This is one complete atom. That means the total number of atoms are 1 by 8 into 8 plus 1, that is equal to 1 plus 1, that is equal to 2 atoms are present in this crystal. Next one is find the packing fraction. For packing fraction, the volume of the atoms in the unit cell by volume of the unit cell. So volume of atoms in the unit cell, V is equal to, according to effective number of atoms, here 2 atoms are present, 2 into the atoms are in spherical shape, that is 4 by 3. pi r cube, that is equal to small v is equal to 2 into 4 8 by 3 pi r cube. This is equation number 1. Volume of unit cell, this is common for all, that is capital V. Capital V is equal to a cube, a into a into a, length into breadth into height, that is equal to, we know, but a is equal to 4r by root 3. So already we calculated this value in the previous page. Substitute this, then v is equal to 4r by root 3 cube, whole cube. This is equation number 2. Now small v by capital V, which is packing factor of BCC, that means is equal to 8 by 3 pi r cube divided by 4r by root 3 whole cube, that is equal to 8 pi r cube by 3 into root 3 by 4r whole cube. This will be reversed. It's equal to 8 pi r cube by 3. Root 3 cube means 3 root 3 by 64 r cube. R cube gets cancelled. 3 gets cancelled. 8 and 64 8 times, that is equal to, the resultant will be root 3 pi by 8, that is equal to root 3 into pi means 3.14 by 8. The answer will be 0.68. You can calculate from your calculator. It is PF 68 or 68%. That means the packing fraction of BCC is 68%. That means in this particular unit cell, the 68% of atoms are occupied in it. The remaining space is void. That means around 32% of space is void. Void means free space. So this gives the density of the material. Okay, thank you.